Ma'am, quiz is based on all experiments, ma'am.
Yeah, it
Yeah,
is
it
based
is
on all
based on all
experiments.
experiments. Okay, ma'am.
Okay. Okay, so let me continue with the Z transform. Okay, last class I told you about the properties of ROC, like based on what type of signal is given, whether it is a right-handed side sequence or left-handed or double-sided sequence. So how do you find the Z transform and how do you identify its ROC and all the properties I've told. So let us understand all this from this example. Okay, so I have an example here, okay, where it says find the Z transform of the following sequences and plot its ROC. So first I've taken a very simple example. X of n is equal to U of n. So you all know what is U of n. It's a unit step function whose value is 1 and it is defined from 1 to, it is defined from 0 to infinity. Okay, and its value is 1. So first let us find out its Z transform. So the Z transform is given by x of z is equal to summation of n varying from minus infinity to plus infinity x of n into z power minus n. So let us substitute u of n in place of x of n. So we have u of n into z power minus n. Now as per the definition of u of n is 1 from where to where? From 0 to infinity. So this index in the summation n now changes to 0 to infinity, and in place of u of n I substituted as 1 and z power minus n. So this becomes 1 into z power minus n or z power minus n. Now this is a infinite series. Okay, so this infinite series, how it will converge? You already know about this formula, right? So if you have summation of n varying from 0 to infinity a power n, it is given by 1 divided by 1 minus a. This converges to 1 divided by 1 minus a, provided your a is less than 1. If a is equal to 1, what will happen? Sum of all ones from 1 to infinity, or if a is greater than 1, this summation will give us infinite, right? So if a is less than 1, it gives us 1 divided by 1 minus a. So whatever we have in this summation, in place of a we have z power minus 1 whole raised to 1. Sorry, z power minus 1 whole raised to n. So I can write 1 divided by 1 minus z inverse. Or if you simplify, I get z divided by z minus 1. So that is your x of z. Next we have to plot its ROC. Now yesterday in one of the property I told, ROC will consist of a ring in the z plane and the centered about the origin. Now if you want to draw a ring, you need to know the radius of the ring. After that you will find out the ROC, right? So for that, let us consider this condition. What is this condition? This summation converges to 1 divided by 1 minus a when a is less than 1. Now in place of a, what I have? Z inverse. So what I do is, yes, so Z inverse should be less than 1 if this x of z has to converge. So if Z inverse is less than 1, 1 by Z will be less than 1 or Z will be greater than 1, correct? Yes, so Z should be greater than 1. This is the condition. So let us plot it. How do I plot? So I'll draw the Z plane here. So Z plane, I have two axes. This is the real part of the Z plane. This is the, real axis, and this is the imaginary of Z. Now, as I told in the first property, it will consist of a ring. Now you have to draw a ring of this radius. Z is equal to 1. Okay. So Z is equal to 1 radius. We are drawing a ring. And as per our convergence, what is the ROC? So this summation x of z will converge to 1 divided by 1 minus z inverse, provided Z inverse is less than 1 or Z is greater than 1. That means what? All the values outside the circle, for all the values of Z which are outside the circle of radius Z equal to 1, your summation x of z will converge. So this is the ROC. The region outside this circle is your ROC because z is greater than 1. This is the region where z is equal to 1, right? So this is z is equal to 1 and inside this is the region z less than 1. Here the x of z will not converge. It will converge only when z is outside the circle of radius 1. This is how you plot. And one more property you can just recall. That property was saying that if the given sequence is a right-handed side sequence, the ROC is outside the circle. Yes, you can observe that because U of n is right-sided sequence. It is defined from n is equal to 0 to infinity. That's how we got ROC outside the circle. Okay. So let us go to the next problem. So the next problem is x of n is equal to half power n into u of n minus 2. So what is half power n? It is nothing but an exponential signal, right? So exponential signal is multiplied by u of n minus 2. What is u of n minus 2? It is a shifted step which is defined from n is equal to 2 and whose value is 1 from n is equal to 2 so on till infinity. Okay. So now let us find the Z transform and its corresponding ROC. So first write the formula for the Z transform. X of Z is equal to summation of n varying from minus infinity to infinity, x of n into z power minus n. Now what is x of n given to us? It is half power n into u of n minus 2. So it is half power n into u of n minus 2. So what is u of n minus 2? It is nothing but 1, right? From where to where? From 2 to infinity. So the index in the summation now becomes n equal to 2 to infinity because this exponential signal when I multiply with a step which is defined from 2 to infinity, the overall signal will also be defined from 2 to infinity. So we have 2 to infinity, half power n, this is 1 as you all know. So 1 into this is this and z power minus n. Now they have the common powers, right? So combine them, half into z power minus 1 whole raised to n. Again, this is an infinite series. Now I have to find out the infinite series. To what value it will converge. So once again use this formula. So we have earlier for the previous problem I had defined from 0 to infinity. Now instead of 0, if you have any summation which is starting from an arbitrary value k. So when n varies from k to infinity, alpha power n, this becomes alpha power k divided by 1 minus k. Now for us it is defined from 2 to infinity. So this becomes alpha power 2 divided by 1 minus alpha. And this converges provided alpha is less than 1. So this condition we have to use to find out its region of convergence. Okay, so in place of alpha what I have 1 by 2 in 1 by 2 into z power minus 1. So it is alpha square, right, in the numerator. So it is 1 by 2 z power minus 1 whole square divided by 1 minus alpha, 1 minus 1 by 2 z power minus 1. So can simplify to get this answer. Now next let us find out the region of convergence. So use this condition. So if this infinite summation has to converge like similar to this, right? If this, because it is same as this, if it has to converge, alpha should be less than 1. So in place of alpha I have 1 by 2 into z power minus 1. So I write here 1 by 2 z power minus 1 is less than 1, or it becomes 1 by 2z is less than 1, or 1 is less than 2z, or z is greater than half. Correct? So the x of z will converge provided the z value should be greater than half. For all the values of z greater than half, this x of z will converge. Okay, so this is the region of convergence. Now, how do you plot that region of convergence? So consider the z plane here. Okay, I have plotted the x-axis, real part of z, imaginary part of z. Now, what is your ROC? Z is greater than half. So what you do here? You draw a ring of radius half. And it says that for all the values of z greater than half. So this is the outside this circle. So this is the region which is z greater than half for which your x of z converges. Okay, so this is your ROC which is outside this circle. So once again, as you can see, the signal is half power n into u of n minus 2. U of n minus 2 is defined from 2 to infinity, right? Once again, this is also a right-sided sequence. So that's why you could get ROC outside the circle. Okay, so let us move on to the next example. The next example is x of n equal to 2 power n into u of minus n minus 1. So let us see, this is an unit step. Let us see what is the range for which this is defined. So I've just plotted here, you can observe u of n minus 1 is the shifted unit step. So n minus 1 means it will be defined from 1, right? So u of n minus 1. Now here in u of n minus 1, if I just reverse n, what will happen? N will become minus n. So you are flipping the signal about this vertical. You are folding the signal about the vertical axis. So the entire thing goes towards left hand side. Mirror, you are taking mirror image. Now u of minus n minus 1 will be defined from minus infinity to minus 1. Fine. So that's what I've written. As per your definition, in the summation, the index will vary from minus infinity to plus infinity. But as per the given sequence, our signal is varying from where to where? Our signal is defined from where to where? Is defined from minus infinity to minus 1. So I've written here from minus infinity to minus 1, 2 power n. U of n minus 1 is 1. So it's not written here. So I can just write into 1 into z power minus n. Okay. Now this is a summation, right? This is a summation. So minus infinity to minus 1. Now they have the common powers. So I've combined 2 into z power minus 1 whole raised to n. Okay. 2 into z power minus 1 whole raised to n. Now in this index, I have the negative sign, minus infinity to minus 1. Since it is a summation, if I change this index to minus 1 to minus infinity and put here 2 into z power minus 1 whole raised to n, the meaning will not change because you are just summing up the terms for all these values. Fine. Now, I want to remove the negative sign which is in the index minus 1 to minus infinity. So what I'll do, I'll make this plus and that minus I'll carry here. Okay, both will be same. Fine. So now this becomes n is equal to 1 to infinity. Now when I take minus here, 2 earlier which was 2, now it becomes 2 power minus 1 and z power minus 1 will become z. So I have here 2 power minus 1 into z whole power n. So once again, this is an infinite series which has to converge. Like previously I showed you, right? From k to infinity. So it will converge to alpha power k divided by 1 minus k. Now in place of k, what I have? I have 1. So this converges to a power 1 divided by 1 minus a. And this will converge provided a is less than 1 for all the values of a which is less than 1. Fine. So I have written here in place of k what you have? 2 power minus 1 into z. So 2 power minus 1 into z divided by 1 minus a, 2 power minus 1 into z. So this is the simplification x of z. Now let us find out its ROC. So to find out its ROC means the set of all values of z for which this summation will converge. So this formula, this is same as this formula, right? Yes, it will converge for a less than 1. In place of a, what we have? 2 power minus 1 into z. So I take 2 power minus 1 into z less than 1, or z by 2 is less than 1, or z by 2 is less than 1, or z is less than 2. That means what? This x of z will converge for all the values of z which are less than 2. Which are less than 2. So this is your ROC. ROC is what? Set of all values of z for which the summation x of z will converge, right? Yes. So for our problem, ROC is set of all values of z for set of all values of z which are less than 2. If this x of z has to converge. Yes. Now how do you plot that? Yes, same as the previous problems. Take the z plane. This is the z plane. Okay. The real part of z and imaginary part of z. Now I have drawn a ring in the z plane of radius 2. Okay. Now as per our ROC, it says all the values of z which is less than 2. So the region inside this ring is less than 2. The region outside the ring is greater than 2. For us, which is ROC? The region which is less than 2. So this is your ROC, which is indicated within this ring of radius 2. So this is your ROC. So as you can remember, the property which was saying if the given sequence is a left-handed side sequence, then ROC will be within the circle. Yes, you can find that the ROC for this is within the circle because our sequence was defined on the left side for negative values of n, that is from minus infinity to minus 1. Okay. So let us take another example where the signal is defined on both the sides. So you can just see we have x of n is equal to 3 into minus 1 raised to n u of n minus 2 into 3 power n u of minus n minus 1. Fine? Okay. Now this is the x of n given to us. So let us first find its Z transform, then we'll go for finding its ROC. So here I have written the expression for finding the Z transform of a given sequence x of n. Fine. So now I'll substitute for x of n. So what is our x of n? 3 into minus half raised to n u of n. Yes. And one more is 2 into 3 power n u of minus n minus 1. Right? So this is being substituted. But since you have two terms, this summation I am applying twice. Once for the first term and once for the second term. Now first term, as you can see here, this 3 into minus 1, 3 into minus 1 divided by 2 whole raised to n is multiplied by this unit step function. Unit step function is defined for 0 to infinity. So this index in the summation now ranges from 0 to infinity. 3 is a constant I have taken outside, and here they have the common powers, so I have combined minus 1 by 2 into z power minus 1 whole raised to n. Similarly, as we saw in the previous problem, u of minus n minus 1 is defined from minus infinity to minus 1. Or if I take the negative sign inside, it will change to infinity to 1, provided we take this negative sign and put it to n here. Okay, so here minus 2 is a constant which is being taken outside, and because we have u of minus n minus 1, n is defined from minus infinity to minus 1, and these have the common powers. So 3 into z power minus 1 whole raised to n. Fine. Now this is converged here. So this infinite series formula I have taken. N is equal to 0 to infinity. A power n or alpha power n is equal to 1 divided by 1 minus alpha. Okay. So that becomes what? 1 divided by 1 minus alpha. Place of alpha what I have? 1 by 2 into z inverse. Fine. Okay. So this one, as I told, this negative sign, if I remove from this index and put it to minus n, so this becomes n varying from 1 to infinity. Wherever 3 is there, it has become 3 power minus 1. 3 power minus 1 is nothing but 1 by 3, and z power minus 1 has become z. Okay. So once again, what is the formula for this? When n is varying from 1 to infinity, alpha power n. When n is varying from k to infinity, alpha power n is alpha divided by alpha power k by 1 minus alpha. In place of k, I have 1. So it is 1 by 3z divided by 1 minus 1 by 3z. So this is your x of z. Okay. Now you have to simplify it. So when you simplify, so 3 into z by z plus half, 2 into z by z minus 3. So this is the simplification. Now here you can take z plus half and z minus 3 as common. Okay, LCM you take and then you multiply with the terms in the numerator. So this becomes your x of z after simplification. Fine. Now we have to find out, this is x of z, okay. Now we have to find out for what values of z this x of z will converge. Yes. So as per our formulas, so this formula and whatever formula we have used here, they say that these two can converge, whatever I have written here, provided your alpha should be less than 1. Now for the first term, your alpha is half power z power minus 1. For the second case, it is 1 by 3 z. Yes. So for the first term, it is half into z power minus 1 is less than 1. So here it becomes 1 by 2z, 1 by 2z less than 1, or z is greater than half. And for the second term in place of alpha what I have? 1 by 3z. So this becomes 1 by 3z less than 1, or z is greater than 3. Now you can observe here I have two conditions. One is z greater than half and the other one is z less than 3. So what I do is, now to plot the rings, now I have two values of z, right? So what I do is, in the z plane I'll draw two rings. One ring of radius 1 by 2. This is of radius 1 by 2. This is not according to the scale. Okay. So this is the ring of radius 1 by 2 and this is the ring of radius 3. So as per this, and we have to take the values of z such that both the conditions are satisfied. Z should be greater than half and z should be less than 3. That means to say the set of all values of z which are greater than half and less than 3, for those values this x of z will converge. Okay. So as you can see, I've shaded the part in between. So this region which is shaded indicates that it is greater than half and it is less than 3. So within these two rings you have the ROC. So this is your ROC. Okay. So if you can remember, we had a property saying that when the given sequence is a double-sided sequence, then ROC will be a concentric ring. Yes, of course, we have got here concentric ring because the given sequence was a double-sided sequence. That means it was defined both for the positive values of n on the right hand side and for the negative values of n on the left hand side. Okay. So this is another problem. So where you have x of n is equal to, this is a finite sequence. Now previously, what in the four examples, whatever I had taken, they were of infinite sequence. So infinite sequence, right-handed side, that is from 0 to infinity. One more infinite sequence which was defined on the left-hand side, okay, from -1 to minus infinity, and the other sequence which was defined on both the sides, infinite sequence. Now here, whatever I have taken, it is a finite sequence. So as you can observe from here, you have half power n multiplied by u of n minus u of n minus 10. Okay, so it is from where to where? U of n is defined from 0 to infinity, whereas u of n minus 10 will be defined from 10 to infinity. It is defined from 10 to infinity. When you subtract them, all the values which are defined from 10, they get cancelled. So you are left out with the samples which are defined from 0 to 5. So our index now changes to n varying from 0 to 9. First, let me tell you this equation. So this is our Z transform equation. X of z is equal to n varying from minus infinity to plus infinity. X of n into z power minus n. Yes. So in place of x of n, what I have? Half power n into u of n minus u of n minus 10. And we know that this is a unit step, right? Whose value is 1. So half power into 1 is, I get half power n itself into z power minus n. Now this signal, this difference is defined as I showed you here. All the values above 10, that is from 10, will get cancelled, right? So the sequence is defined only from 0 to 9. So the index in the summation varies from 0 to 9, and here same powers have combined, half into z power minus 1 whole raised to n. Now this is a finite series. So what is the formula that we use to solve this finite series? So this is the formula. What is this? So summation of n varying from 0 to n minus 1 alpha power n is equal to 1 minus alpha power n divided by 1 minus alpha. So this finite series can be solved as 1 minus alpha power n divided by 1 minus alpha if alpha is not equal to 1. If alpha is equal to 1, then that's, if you add all ones from 0 to n minus 1, I'll be getting n as the answer. So I have here alpha which is not equal to 1, right? So I have to use this. Okay, so in place of n minus 1, what we have here? 9. Fine, I have 9 here. So 1 minus alpha is 1 by 2 z inverse whole raised to n. N minus 1 is 9, means n should be 10. So it is 1 minus half into z power minus 1 whole raised to 10 divided by 1 minus alpha divided by 1 minus alpha. So you can take LCM between these two terms and you can simplify. So you can simplify here. Okay. So this is the finite, this is the Z transform of the finite sequence. Now, in case of previous problems, you could have seen they were the infinite sequences. Okay, and you could have seen the convergence was depending upon the what is the z value, what is the z value based on the formula used. But here it says alpha, when alpha is not equal to 1, this is the formula. Yes, so our alpha 1 by 2 z power minus 1 is not equal to 1, that's why it is converged. So as you go for the properties of ROC, it says that whenever the given sequence is a finite sequence, the ROC is the entire plane except for z is equal to 0 and z is equal to infinity. Yes, let us check that. So in this x of z, after solving whatever x of z you have got here, you just consider this x of z. Now this x of z, you put any value of z, this will give me a finite answer except for z is equal to 0 and z is equal to infinity. Now in this, if you put z is equal to 0, because z is in the denominator, right? So this becomes, x of z becomes infinity. Even when you substitute z is equal to infinity, this becomes infinity. So I can say for this problem, ROC is the all values of Z present in the Z plane. So I can say entire Z plane except at Z is equal to 0 and Z is equal to infinity. So now let us plot this ROC. Okay, so I can say entire Z plane except Z is equal to 0 or Z is equal to infinity. Okay. So we have taken the ROC. Now what are all this? It's nothing but the zeros and poles we have plotted. So you can see in the x of z expression I told you, in the if you solve the numerator of x of z, we get the zeros. So I have z power 10 minus half power 10. So these will give me the zeros. The denominator will give me the poles. So these are zeros and denominator poles. How many poles are there? As you can see here, z power 9 into z minus half. This will give me 9 poles and this will give me 1 pole. So I have 9 poles at the same point, z power 9. Okay. And this is half. So as per our properties, your Z plane is, yeah, sorry, your ROC is the complete Z plane except Z is equal to 0 or Z is equal to infinity. So these are the some of the examples which are shown to explain you uh, to find out the Z transform and how to find out the ROC given any sequence as defined. Now, here I have taken another example. So, uh, this is the signal is a right-handed side sequence. What is the speciality of this problem is, in the previous cases, when you got a problem on right-handed side sequence, you had only one condition. But here we'll get two conditions. That means I'll get two rings here. Okay, so when you have two rings, which one has to be selected for ROC? So first, if you go through the problem, you will understand. So let me tell you that. So you have x of n is equal to 7 into 1 by 3 raised to n u of n minus 6 into half power n u of n. So I take the formula for x of z. X of z is summation of n varying from minus infinity to plus infinity, x of n into z power minus n. Fine. I've substituted for x of n. This is your x of n. Now have two terms. This is one term. This is one term. So taken here. What is u of n? It's 1. Okay. So the index in the summation becomes 0 to infinity because u of n is defined from 0 to infinity. So leaving u of n because they are 1, I have 7 into 1 by 3 raised to n, 6 into 1 by 2 raised to n into z power minus n. Now since I have two terms, I have applied the summation twice. You can see 7 is the constant which is taken out. Then I have n varying from 0 to infinity. Okay, 1 by 3 to z power minus n. So same power I have combined here, 1 by 3 into z power minus 1 whole raised to n. Similarly here, 6 is taken out because it's a constant and 1 by 2 and z power minus n. Fine. Now, so this is an infinite series. So what is the formula? You all know. N varying from 0 to infinity alpha power n is equal to 1 divided. You all know Okay, I'm just recalling 1 divided by 1 minus alpha, and this condition is, you can simplify the summation to 1 divided by 1 minus alpha provided your alpha is less than. The same formula is used here. So 1 divided by 1 minus alpha. In place of alpha, what I have? 1 by 3 z inverse. Yes. Here 1 by 2 z inverse. Fine. Okay. So now we have simplified. So by taking the LCM, we have simplified. So this is the x of z you are getting. Fine. Now let us find out the ROC. Now, since we have used this equation, we have to consider this condition, right, to find out the ROC. So, as we know, this infinite series will give rise to 1 by 1 minus alpha provided alpha is less than 1. Now, I have two values. Okay, so in the first term, alpha is 1 by 3 z inverse. In the second term, alpha is 1 by 2 z inverse. So, for the first term, it is 1 by 3 z inverse. Second term, 1 by 2 z inverse less than 1. Or if you simplify this, I get z greater than 1 by 3. And here if I simplify, I get z greater than 1 by 2. Z greater than 1 by 3 and z greater than 1 by 2. Okay. Now, the problem is, now I can say I have two z's. Now, which one to select? When I define ROC, I should tell that, I should tell properly, like, what are the values of z for which it will converge? Whether it is all the values of z which are greater than 1 by 3 or all the values of z which are greater than 1 by 2. Which one should I select? So, both are greater than. Yes. So if you get a condition something like this, where z is greater than two quantities, z, say if you take z is greater than a1 or z is greater than a2. Now which one you have to select? You have to select maximum of these two. That is z greater than maximum of 1 by 3 and 1 by 2. Okay. So out of this, which is maximum? It is 1 by 2. So I can say ROC is all the values of z which are greater than 1 by 2. This x of z will converge. Okay. Now I have to plot it, right? So while plotting, I have two rings. As per the given for problem, I have two rings. One ring of radius 1 by 3, the other ring of radius 1 by 2. So our ROC is all the values of z which are greater than 1 by 2. So I have indicated outside the outermost ring. Outside the outermost ring. This is your ROC. Okay. Now similar to this, if you get a case something like this, z is less than a1, z is less than a2. What will you do here? If you get any problem,
Minimum of A1 and A2.
yes, minimum of a1 and a2. Okay, fine. So these are about some of the problems and finding the ROC. Yes. In the next class, I'll start with the properties of Z transform.